Welcome to Derivatives, Lesson 2, Definition of a Derivative. Today we will talk about how to find the definition of a derivative and then going from there to using it. So let's go ahead and talk about slope, because that is all about what a derivative is. It's a slope of a line. You're finding the slope of a line that is tangent to a curve. So let's go ahead and move on to the next screen and we'll do a little bit more talking. Alright, what we have here is a curve. That would be the blue curve there. We have two lines drawn. A secant line. Okay, remember from chapter 10 in your geometry book, a secant line through a circle was either a line that contained a chord or a line that hit a circle twice. And then you also have a red line there that hits the curve at exactly 1 point. So first of all, let's talk about the slope of the black line, the secant line. Let's go ahead and talk about the slope of that line. Eventually you want to find the slope of the red line, but right now let's just find the slope of the black line. As I was saying, we're trying to find the equation of the slope of the black line, delta y over delta x. So what is the change in y's? We're looking at f of x plus h, that's one of the y values, minus the other y value, f of x, all over the x value, x plus c, minus the other x value, c. So the net result is the slope of the black line is f of x plus h minus f of x all over h. And boy, doesn't that look familiar. Okay, what are we doing? We're finding the slope of that tangent line. Now, some cool things are going to happen here. Alright, what we want to do is we want to find the slope of this red line. So what we're going to do is we're going to make this h smaller. Okay, that means we need to move this down to here. And as we make that h smaller, our secant line is going to get closer and closer to the tangent line. Eventually, if we make h really super small, the tangent line will actually be the red line. But there's only one way that we can make that h like really super small. We just spent a whole week on it. That way to do that is to make that h so small that the limit as h approaches 0 of f of x plus h minus f of x all over h. Right here, this puppy, right here that you see, that is the definition of a derivative. Let me see if I can highlight that for you. Right there. That is the definition of a derivative. So now let's go ahead and try to put that into practice. Easier said than done. But you know what? Nobody ever said this was going to be a cakewalk. Nevertheless, we should still have a little bit of fun with it. So let's go ahead and move along. Alright, so we're trying to find the derivative what we're going to call this is f prime of x. F prime of x will be called the derivative of f of x. And that's going to equal the limit as h approaches 0 of f of x plus h minus f of x all over h. Alright, so let's go ahead and replace this in the negative quantity of x plus h, quantity squared, plus 8 times x plus h minus 6, minus 6 minus negative x squared plus 8x, this is f of x that I'm subtracting here, minus 6 all over h. And again, we're still finding the limit as h approaches 0. Oh wow, I should have guessed I should have replaced h with a 0, and it would have been f of x minus f of x all over 0. 0 over 0. Yeah, you're always supposed to replace. Alright, so we've got the opposite, or negative, of x squared plus 2xh plus h squared plus 8x plus 8h minus 6 plus x squared minus 8x plus 6. I love multiplying through by negative 1, and that's all over h. See if I can simplify this for you a little bit more. And I guess I should have probably paused this, shouldn't I? You know what? We're going to pause here, and I want you to simplify as much as you can down to a numerator over h. So go ahead and pause. Alright, so we have the limit as h approaches 0 of negative 2xh minus h squared plus 8h all over h. Notice that all those terms canceled out when we combine like terms. That's a beautiful thing. So let's go ahead and factor out an h. H is a factor in every term in the numerator, and it's a factor in the denominator. So we're finding the limit as h approaches 0 of negative 2x minus h plus 8 when you factor out the h's. Now go ahead and replace one more time, and we find out that f prime of x equals negative 2x plus 8. So we can use this to find the slope on any point of f of x. So if I say f prime of 4, I'm going to find the slope of the line tangent at 4. And that slope would actually be, let's see here, negative 2 times 4 plus 8, that would be 0. So f prime of 4 would be 0. The tangent line is actually a horizontal line right there because the slope is 0. So that's how you use the definition of a derivative. Let's move on to the next one. G of x equals the square root of x plus 2. Alright, we are going to say that g prime of x equals the square root of x plus h plus 2 minus square root of x plus 2 all over h. Now, this should be light should be going off in your head saying, you know what, you're going to do this to us again, messing around with square roots. Well, we want to get rid of these square roots. How would you get rid of these square roots? You would do that by multiplying by the conjugate. You should be recognizing these things right now. So go ahead and multiply by the conjugate, and then come back and we'll look at result. And there you go. Forgot to tell you, yes, you're still finding a limit. Limit as h approaches 0. Okay, I've multiplied by the conjugate. That means this times this minus this times this. Here's the result. Now let's go ahead and simplify that numerator. Go ahead and pause. Okay. The x and the 2, they cancel out when you distribute this -1 and then combine like terms. So we've got h over that stuff, and then we can, since this is a factor and this is a factor, we can cancel and replace with 1s. So it's going to be 1 over. Let's go ahead and replace h with a 0. And you're going to have the square root of x plus 2 plus the square root of x plus 2. That makes g prime of x equal to 1 over, okay, there's 2 square roots of x plus 2, so that would be 2 times the square root of x plus 2. And that's the derivative of g of x. Let's move on to the last one in your notes. And here it is. I'd like you to try to take the derivative of that using the definition. Oh yeah, great. Fractions. Yes, of course, that's why I gave you all those crazy problems a day or two ago. I wasn't just messing around, I was trying to get you ready. Alright, so go ahead and set it up, and then we'll talk about simplifying it. Alright, there's k prime of x. Now, in order for us to do this, we're going to have to get a common denominator with that and with that. So we need to multiply this numerator and denominator by this denominator. We're going to need to multiply this numerator and denominator by this. So go ahead and do that and try to simplify the best as you can, and then come back. So go ahead and pause. And here are the results of you working on that denominator and numerator to get common denominators. Alright, go ahead and now, since you have common denominators right here and here, go ahead and work on these numerators and simplify those as much as you can, and then go ahead and come back and we'll look and see if we're on the same page. Alright, that's where I ended up. Now I've got the division of two fractions, so I'm going to reciprocate, and we're going to have the limit as h approaches 0 of -6h over 3 times the expression x plus h minus 4 in parentheses times 3x minus 4 quantity. Multiply that all times 1 over h. Wow, those h's will cancel out. So in the numerator we've got -6. Go ahead and replace h with a 0 here, and that's just going to be x. 3x minus 4 times 3x minus 4. We're going to end up with 3x minus 4 quantity squared, and that will be, what are we working on? Are we working on h? No, we're working on k. So k prime of x equals that. And if we want to find the slope of any point on that line or of that function, just go ahead and replace it here and replace it there, and that will be the slope. this will end derivatives 2 definition of a derivative.